Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Semiconductor Devices and Integrated Circuit. Let's start with the Unit 2, the Junction Transistor of Lecture 3. The contents that we are going to discuss today are triac and diac. Let's start with the triac. A triac is a 3-terminal semiconductor switching device which can control alternating current in a load. Why it is called as triac means it is having 3 terminal and it is going to operate in a AC circuit. That is why it is called as triac, and it is also called as triode for AC circuit, and it will be going to conduct the current in both the direction. That is why it is called bidirectional device. Let's see how it will going to work in a circuit. If we are going to connect the triac in series with a resistive load and the AC supply is given to triac, it will going to conduct in both the direction, that is in the both positive and as well as negative. That is what we can observe is it will going to act in a positive cycle, it will act like exactly like a SCR. That is why in a VA characteristics we will going to study how the triac will having a same exact characteristics of SCR in a forward mode. That means the SCR forward characteristics and triac are one and the same. The triac construction. The triac will having 5 layer P and P, and we consider these two as another layer N1 and N2. This is also another layer. There will be 5 layer semiconductor device, and it is having the forward characteristics identical to the SCR. It will be having 3 terminals MT1, MT2 and also called as anode 1 and anode 2 respectively. MT1 and MT2 means main terminal 1, main terminal 2, and another terminal is gate, that is third terminal. So, there will be 3 terminals, 5 layers. So, this is how it looks if you represent the triac as a SCR. 2 SCR is connected exactly parallel and it is facing opposite to each other, and the anode of one diode and the cathode of the another diode makes M terminal 2, main terminal 2, and again the anode of one terminal and cathode of another terminal will makes terminal 1. Both the gate terminals are shorted will becomes a gate terminal. This is how the symbol looks. This is what the symbol of a triac. It is exactly looks like an SCR, that is 2 SCR with a gate. Triac operation. Observing in the figure, the triac is connected to the series load resistor and AC supply is given. Again there is a gate circuit which is having variable resistance R. This will going to control the gate voltage. So, we can give the when the MT1 is make negative with respect to MT2, that is MT2 is positive, MT1 is negative. When we give a voltage, that voltage is sufficient for for triac to turn on. That means when the voltage is above or equal to breakover voltage, the triac will going to turn on. This triac will turn on and the direction of current is from MT2 to MT1, since MT2 is positive to with respect to MT1. This is how the SCR works when the gate voltage is made positive, and also when the gate voltage is negative, means when the MT1 is positive with respect to MT2, the current direction is from MT1 to MT2, And also another condition is there, when gate voltage is not applied for a triac, there will be no current and we can say that triac is in off condition. Next we move on to triac characteristics. From the triac characteristics we will observe that the first quadrant will have the exact forward characteristics of an SCR. This is what similar to the SCR characteristics, and also the triac will going to work in both positive gate voltage and also as negative gate voltage. Usually the triac will made to work as a positive gate voltage, and irrespective of terminal polarity will be positive or negative, since it will going to conduct in both the direction. The terminals of polarity, main terminals 1 and 2 is not considered, only the gate polarity is considered. If it is in positive, it comes to the first quadrant. If the gate terminal is negative, it comes to the third quadrant. As when we are going to increase the voltage, till the voltage reaches a VBO, there will be small amount of current, the leakage current will present, and once it reaches the VBO, due to the breakdown, the voltage, there will be a negative, due to the breakdown there will be a negative resistance exist. This negative resistance makes the voltage decrease and increase the current. This due to the negative resistance, the current will going to increase and the voltage will going to decrease. So, this is what we can observe from the VBO, and this voltage will appear across the RL load. Next, some of the points that we do note down from a triac are: triac can conduct current with regardless of the polarity. As I said, the polarity of a main terminal is not at all considered in the conduction of triac, since there is no longer a specific anode or cathode, since both the terminal we name as anode 1 and anode 2, and this the terminal polarity is not at all considered. And triac can be turned on either with a positive or negative voltage at the gate of the device. Like SCR, once triac is turned on or once triac is fired, the gate loses all the control. The triac can be turned off only by reducing the supply voltage, as like a SCR. The main disadvantages of triac, the main disadvantage of triacs over SCR is that triacs have considerably low current handling capabilities. This can be the main disadvantages when we compare SCR with the triac. This triac only operates with a low current handling circuit. Most triacs are available in ratings of less than 40 amps at voltage up to 600 volts. This is the range at which the triac will going to work. Next, some of the applications of triac. As a high power lamp switch, we can use a triac. In the electronic changeover of transformer taps, we use the triac as an application. Next, we move on to another type of an thyristor, that is diac. All these triac, diac, SCR we called as a thyristor. Why? Because these devices can be completely switched on or switched off, that is why it is called as thyristor. Next is diac. Diac means diode operating in AC current is called as diac, and it is having two terminals, 3 layer, which can be switched on or switched off either by applied voltage, for either polarity of applied voltage. This is also bidirectional, it can be operated in both the direction. The diac can be constructed in either NPN type or PNP types. From the symbol we can observe it is having 3 layers P and P. So, this can be constructed either from PNP type material or NPN type material, and the 2 LEDs are connected to P regions of silicon separated by N region. And the structure of diode is very much similar to that of a transistor. However, there are some important points we need to note on. The structure exactly looks like a PNP, which makes us confusing, but there is some difference in the layer. Now, what are the points we need to remember is there is no terminal attached to the base. Yes, there is no terminal, only 2 terminals are present, and the 3 regions are nearly identical in size. But in transistor, the middle region is very thin and it is slightly doped. That is why in the transistor and diac have difference. The region are having identical size, and the doping concentration are identical to give the device symmetrical property. These three are the difference between diode and transistor. Since it looks like a transistor, but it is having a different property than the transistor. This is the diode symbol, which is looking like a triac, but here there is no gate input here. By removing the gate, we can make a triac as a diode. So, let us see how the VI characteristics of an diode will be. This is show the voltage across the current curve when we are going to give voltage when across the terminal till the voltage reaches VBO, that is break over voltage, the diode will be in off conditions. So, the diode will be in turn off conditions. So, once it reaches VBO, once it reaches the voltage break over voltage, it starts conducting due to the reverse breakdown in a junction. In the middle junction there will be a reverse breakdown, that is in a N region there will be reverse breakdown. Due to this there will be exist of negative resistance. Negative resistance means as the current increases, the voltage decreases. The current is increasing here, the voltage is decreasing. So, at some point the voltage will decreases to a value, that point is called as break back voltage. This point is VW and this voltage is called as break back voltage. Till now it will going to increase the current to a range which is called as forward current, and due to the breakdown of a reverse junction we will get a negative resistance. Due to that negative resistance, the voltage will be decreased, the current will be increased, and the voltage will reach a certain point called break back voltage, and it is mentioned as VW. And we can observe that IBO, the current breakover point, and the voltage breakover point are same. So, it indicates that the both current breakover current and the voltage breakover will be of same value. The reverse characteristics of a diode will be same. When negative applied voltage is increased at certain point due to the breakdown, there will be again the increase of current due to the decrease of a voltage. This shows the diode operation, and this is the VI characteristics of diode. And we also note that the voltages of VBO and minus VBO are breakdown voltage, and usually the VBO, minus VBO and plus VBO of range 30 to 50 volts. In below this we will say that diode will be in turn off condition, and above this voltage we will say that diode will be in turn on condition. Let us have a short break. Welcome back after a short break. Before break we are across with the VI characteristics of diode, and we know how the voltage will going to decrease with the increase of voltage when the diode will crosses above the breakover voltage, and when it is going to reach a specific voltage called break back voltage, it will be having a current of forward current. These are the things we are note down about the VI characteristics of a diode, and it be having IBO and VBO of same value, that is the diode will be having a breakover current and breakover voltage of same value. It will going to operate in both positive and negative direction, and in both the direction below the B plus VBO or below the minus VBO, the diode can be set as a turn off condition. The diode can be set to be as a switch off, and the diode will be having breakover voltage of range 30 to 50 volts. This is a range that the diode will have a breakover voltage. This is what we can infer from the curve of a VI characteristics. Next we move on to some of the applications of diodes. Diodes are used primarily for triggering of triacs in adjustable phase control of AC mains. Since I said this diode having as looks the symbol looks like exactly like a triac when we remove the gate terminal of a triac. So, when the gate terminal is made connected to the diac terminal. This diac terminal will going to operate as a triggering circuits. Since a diac is usually used for the phase control of a AC load, the diac will be mostly used as a triggering circuit for the triac. When triac is adjustable phase control of AC mains, we are going to use a diac as a triggering circuit. Where we usually use the diac means lamp dimmer as a triggering circuit. We use in a lamp dimmer we use diacs as a triggering circuit, and heat controlled circuit we are use diac as a triggering circuit for triac. Till now we have discussed about triac and diac. Triac will going to operate in both the direction, and gate will going to control the operation of a triac, whereas in the diac also a bidirectional device. The current will going to flow in both the direction, but there is no controlling gate. We also know that the application of triac and diac. We know that diac is going to use as a trigger circuit for the diac. Diac will going to use as a trigger circuit for a triac. So, this can be studied by using a lamp dimmer. How diac will going to use as a trigger circuit for a triac, and also how the triac and diac will going to make a lamp control, how we are going to make a lamp dimmer circuit using diac and triac. Here the triac and diac will control by a RC, varying the RC values we are going to control the lamp output, that is the supply voltage will be controlled. The AC supply voltage will smoothly controlled with the help of triac diac circuit. The circuit will be shown like this. This is having many R and C which are connected, some of in series, some of in parallel, and here the C1 and R4 are in series. This C1 and R4 will be useful when the triac is has to be in half state. The rising voltage will be limited across the device by using this C1 and R4 series. How we are going to control the output of a AC supply with the help of triac and diac is due by varying this R2 resistance. The varying the R2 value, we can change the input for the diac. So, here we have C2, C3 which is feeding to the diac. So, when we are going to give a positive voltage, the capacitor C1, C2 will charges. When the C3 will charges up to the breakdown voltage of a diac, the diac will turn on. When the diac will turn on, the diac will going to make the current to flow through it, and therefore, the diac is going to connect to the gate of a triac. Since the diac is in turn on, the current also flow to the gate. So, we can observe that by varying the resistor value, we can vary the voltage of a diac operation. Once we get the breakover voltage for the operation of a diac, the triac also triggered on due to the turning on of diac. So, once the triac is turned on, particular point of a positive voltage, by varying the resistor value R2, the lamp will be controlled with the help of varying the value of R2. So, what we observe means, by varying the value of R2, we can make a capacitor charging and discharging. Once a capacitor is charged for a voltage up to the breakover voltage, it starts discharging. The C3 will start discharging. This discharging voltage will appear across the diode, which will going to form a breakover voltage and makes the diac will operate in a on mode. This will turn on the diac, and with this in turn turn the triac. So, diac will going to act as a triggering circuit for the triac and makes the triac also in a conduction mode and makes a lamp to glow, and this is how we can control the lamp by a diac and triac circuit. This circuit is called as a lamp dimmer, and the output will be shown here in the figure. This is the AC supply voltage. This is a controlled output getting out of the triac, which is given into the lamp. This dotted line indicates the in a positive half cycle. This shaded portion indicates the conduction region. This is where we can we can make use of a positive cycle conduction, and here in the negative cycle, the shaded portion indicates the conduction region, and we can observe from the figure only till 180 degree we can control. either positive or negative, we can control till only 180 degree. So, by varying the resistor value, we can vary the firing angle of a triac by making the diac turn on. This will make us to use a triac and diac in a lamp dimmer circuit. Next, come to the summary. We know about triac, that is a thyristor for AC alternating current, and which is going to conduct in both the direction, so that we will going to have a control the AC current in AC in both the direction, and we can fed the load with the appropriate and with a smooth voltage, and the characteristics we come across, and also its application. Diac is also a bidirectional device which is going to use as a triggering circuit for the triac. The characteristics of triac and also the break back voltage we come to know in the characteristics, and the due to the negative resistance what happen in the VI characteristics, that is also we come to know, and its application which is mainly as a triggering circuit for the triac. Now, some of the questions of this session: what are the symptoms of a shorted diac or triac? It means when we are going to short diac or triac means when it is closed. What are the symptoms? What are the characteristics of diac and triac? Next, what are the symptoms of an open diac or triac? Next, why is diac preferred to trigger a triac? These are some of the questions of this session. For the further reading, you can refer www.talkingelectronics.com, www.electronicstutorial, and for further reading, you can refer the book Electronic Devices and Circuits by G.K. Mittal. This ends up the session. Thank you.